What's up, everyone? We need to talk about something absolutely extraordinary that's happening right now in our solar system. And honestly, the implications of this are mind-blowing. NASA has just released new images of 3I/Atlas, and what these images reveal has sent shockwaves through the scientific community. For those of you who don't know what 3I/Atlas is, buckle up, because you're about to learn about one of the most fascinating discoveries in modern astronomy. We're talking about an object that didn't originate in our solar system. We're talking about something that traveled through interstellar space from another star system and is now passing through our cosmic neighborhood. And the new data we're getting is challenging everything we thought we knew about what exists out there in the vast darkness between the stars. Let me set the stage here because this story is absolutely incredible. On September 13th, 2024, astronomers using the Atlas survey system in Hawaii detected something unusual. At first, it looked like just another comet, which wouldn't be particularly remarkable because we discover comets all the time. But as they collected more data and analyzed the trajectory of this object, they realized something absolutely stunning. This wasn't a comet from our solar system. The orbital calculations showed that this object was moving way too fast and on a path that couldn't be explained by the gravitational influence of our sun. This thing came from somewhere else, from another star system, from interstellar space. This is only the third confirmed interstellar object we've ever detected passing through our solar system. The first was Oumuamua, discovered in 2017. Which created a massive sensation and spawned countless theories about what it might actually be. Some scientists suggested it could be a nitrogen iceberg from a Pluto-like world. Others proposed it might be a fragment of a shattered planet. And yes, there were even serious scientific papers suggesting it could potentially be artificial, some kind of probe or spacecraft from another civilization. Then we had Borisov, discovered in 2019, which was clearly a comet and behaved pretty much exactly as we'd expect a comet to behave. And now we have 3I/Atlas. And folks, this one is different. This one is revealing things we never expected. The new images that NASA has released show something extraordinary. Using multiple telescopes, including the Hubble Space Telescope and ground-based observatories, astronomers have been able to capture unprecedented detail of this interstellar visitor. And what they're seeing is challenging our understanding of how objects behave in the extreme environment of interstellar space. The images show that 3I/Atlas has a tail which suggests it's actively outgassing, releasing material as it gets closer to our sun. But here's where it gets really interesting. The composition of that tail, the materials being released, include compounds that we don't normally see in solar system comets. We're talking about unusual ratios of carbon monoxide to carbon dioxide. We're seeing organic molecules that suggest this object formed in a very different chemical environment than anything in our solar system. Think about what this means for a moment. This object spent potentially millions or even billions of years traveling through the frozen darkness of interstellar space. It left its home star system, possibly ejected by gravitational interactions with planets or other objects, and then drifted alone through the void. The temperatures out there in interstellar space are incredibly close to absolute zero. We're talking about minus 270 degrees Celsius. At those temperatures, chemical reactions essentially stop. Time, in a sense, freezes. This object is like a time capsule, preserving conditions and materials from another star system, from a place that could be dozens or hundreds of light years away. The spectroscopic analysis of 3I/Atlas is revealing the chemical fingerprint of another stellar neighborhood. Scientists can look at the light reflected off this object and the light emitted by its outgassing, and from that, they can determine what elements and compounds are present. And what they're finding is fascinating. The isotope ratios, the relative abundances of different elements, tell a story of formation around a star that was different from our sun. Maybe it was a cooler star, a red dwarf. Maybe it was a hotter star with different radiation patterns. The point is, we're literally looking at a piece of another world, and it's telling us about conditions in a place we could never visit with current technology. But there's something else about these new images that has scientists really excited and, frankly, a little bit puzzled. The structure of 3I/Atlas appears to be unusual. High-resolution images show what might be a fragmented or fractured surface. There are variations in brightness across the object that suggest it might not be a single solid piece, but rather a loosely bound collection of smaller pieces held together by gravity and possibly by frozen ices acting as a kind of glue. This is important because it tells us about the violence this object might have experienced. Did it fragment when it was ejected from its home system? Did it collide with something during its long journey through interstellar space? Or is this fragmentation happening now as it gets heated by our sun? The trajectory of 3I/Atlas is also providing valuable information. Scientists have worked backwards, using the object's current path and speed, to figure out roughly where it came from. And while we can't pinpoint an exact star of origin, we can narrow down the general direction. The calculations suggest it came from somewhere in the direction of the constellation Lyra, and it's been traveling for potentially tens of thousands of years to reach us. Just imagine that. This object has been on a journey through space for longer than human civilization has existed. It's seen parts of the galaxy we've never seen. It's experienced conditions we can barely imagine. Now, there's always the question that comes up whenever we detect an interstellar object. Could it be artificial? Could it be a spacecraft or probe from an alien civilization? And look, I want to be really clear here. The scientific consensus based on all available data is that 3I/Atlas is a natural object, a comet or comet-like body. But scientists are rigorous. They're checking. They're looking for any anomalies in its trajectory, any signals being emitted, any structures that couldn't be explained by natural processes. So far, everything points to this being a natural interstellar comet. But the fact that we're even asking these questions shows how transformative these discoveries are. We're now living in an era where interstellar objects passing through our solar system are not just theoretical possibilities, but observed realities. The implications of studying 3I/Atlas extend far beyond just understanding this one object. Every interstellar visitor gives us a window into the diversity of planetary systems in our galaxy. You see, when planets form around a star, not everything gets incorporated into planets. There's leftover material, debris, small bodies that orbit in the outer reaches of star systems. And sometimes these objects get gravitationally kicked out and sent on journeys through interstellar space. By studying objects like 3I/Atlas, we're essentially sampling material from other planetary systems without having to travel there. It's like the universe is delivering samples to our doorstep. This also has huge implications for astrobiology, the study of life in the universe. One of the big questions in science is how life originated on Earth. There's a hypothesis called panspermia, which suggests that the building blocks of life, or even simple life forms themselves, could be transported between star systems on objects exactly like 3I/Atlas. If these interstellar visitors contain complex organic molecules, and we're finding evidence that they do, then they could have seeded early Earth with the chemical ingredients necessary for life to emerge. It's a mind-blowing concept. The chemicals in your body right now might have originally come from another star system, delivered by an ancient interstellar comet billions of years ago. The new images are also helping scientists understand the dynamics of our galactic neighborhood. How common are these interstellar objects? For a long time, we thought they must be incredibly rare because we'd never detected any. But now that our telescopes and survey systems have improved, we're finding them. First Oumuamua, then Borisov, now 3I/Atlas. And statistical models suggest that at any given time, There might be dozens or even hundreds of interstellar objects passing through our solar system, too small or too far away for us to detect with current technology. Space, even our own little corner of it, is far more dynamic and interconnected than we ever realized. There's also a growing movement among scientists to propose a dedicated mission to intercept and study an interstellar object. 3I/Atlas is moving too fast for us to reach with current spacecraft, but if we can detect the next one early enough, we might be able to launch a probe to rendezvous with it. Imagine the science we could do with a spacecraft actually touching down on an object from another star system. We could analyze its composition in detail, drill into its surface, search for organic molecules and potentially even biosignatures. It would be one of the most important missions in the history of space exploration. The images NASA has released show 3I/Atlas in exquisite detail, but they also remind us of how much we still don't know. Every answer raises new questions. Where exactly did this object come from? What kind of planetary system ejected it? How long has it been traveling? What experiences did it have during its lonely journey through the void? Did it pass close to other stars? Did it witness supernovas or traverse giant molecular clouds? We're looking at an object that has a history spanning potentially millions of years and countless light years, and we're only just beginning to decode that history. What's particularly exciting is that this is happening now, in our lifetime. We're the generation that's discovering interstellar objects for the first time. We're the ones who get to study these cosmic visitors and piece together what they tell us about the galaxy beyond our solar system. Future generations will look back at this era as the beginning of interstellar science, the moment when we started to truly understand that our solar system is not isolated, but part of a vast, interconnected galactic ecosystem where material and possibly even life itself travels between the stars. As 3I/Atlas continues its journey through our solar system, telescopes around the world will keep watching, keep imaging, keep collecting data. Every observation brings us closer to understanding not just this one object, but the nature of the galaxy itself. We're living in an incredible time for astronomy, a time when the universe is revealing its secrets faster than ever before. And this interstellar visitor, this traveler from another star system, is teaching us that space is not empty, that the galaxy is alive with movement and exchange, and that we're part of something far grander than we ever imagined. The shock isn't just what NASA's images show. The shock is what they mean. We're not alone in the galaxy in terms of being part of a dynamic, interconnected cosmic community where objects, materials, and possibly even life itself travels between the stars. And that realization changes everything.